start today's lecture. This week is the third week. Because for each week, I only spend 2 hours to talk about a computer vision lecture. So our procedure a bit late. So today I will continue to talk about camera model. And next week, we won't have a class next week because school birthday something like that. 下礼拜好像我看 schedule 是不是，应该是学校那个什么校庆是校庆，反正我看那个 schedule 是好像校庆的样子。School annual 那个学校校庆嘛，校庆补假。So next week we won't have a class. 不要来这边啊。So we continue our lecture about camera model. Also today my class will be end about 11:30 because I have the other project, big projects, and the government people, professor will visit here to check our results. So today lecture will be until 11:30. I will need to go to the arena, sports arena. 他们那个我们有个大计划，800万大计划，他那个要来 check 我们今天的结果这样子。好，所以今天只上到11:30这样子。抱歉，因为他一年就 check 那么一次，就是看到明年要不要再发800万给我们这样子。So we'll continue our lecture about camera model. So this lecture, okay, for the first part, I will just first chapter, I just briefly introduce what's the computer vision, what's the camera. But in the second chapter, we talk about this one. We start talking about what's the definition for camera model. And because most of the camera model is developed by they try to simulate our eyes. 很多的 camera model 是模仿的眼睛哦。So we call pinhole camera model because our eyes are the model of a pinhole. Okay, 针孔. So this is the camera model here. So in the second chapter, I will introduce you what's the theory about the camera model. So after this one, after camera model, and in camera model, the most important one is between this one, in the pages 39 and 38. So what's the relationship between 2D and 3D? Okay, because like our eyes, we see up here, we see anything. It's a 3D scene, we call scene, 3D scenes. However, if you take the image is 2D. So what's the relationship between 2D and 3D? The relationship between 2D and 3D, that's camera model. The inside camera model, we call modeling. The modeling usually has the parameters. The Gaussian model. The Gaussian model has parameters, mean and standard deviation. And in the camera model, we have parameters we call intrinsic parameters. We also have extrinsic parameters. And third one is the lens, the distortion parameters. So there are 3 sets of parameters to form the camera model: intrinsic, extrinsic, and distortion camera model. Parameters. So that's what I try to teach you in the chapter 2. Okay. In chapter 3, okay, we talk about the camera model. So it's between 2D and 3D. So important things are how can you reconstruct the object from 2D to 3D. And we have a different kind we have a perspective geometries, we have a orthogonal perspective projection model, we have an orthogonal projection model, we also have a weak perspective model. So I will tell you just the concept about this one. Okay. And the camera model, the pinhole camera model is perspective projection model. Perspective projection meaning if the object close to you, you'll feel it's bigger. The scaling is bigger. If the object far away from you, it's smaller. That's called perspective projection. But that one is not easy to reconstruct 3D. So people start to think about how can you reconstruct from 2D to 3D. So one famous one we call weak perspective model, this one. So I will let you know. In the chapter 4, the important even 3D, between 2D and 3D are the parameters. How can you solve the parameters? Like I teach you deep learning. How can you solve the parameters of deep learning? We use stochastic gradient descent. But here, how can we solve those parameters? The important one we call homogeneous. So homogeneous is a matrix to solve all kind of parameters. Homogeneous 不是只有一种 ，homogeneous 是一个通用，是 homogeneous matrix. Any equation, anyone, if you want to solve the parameters, okay, you should use homogeneous matrix and then apply we call optimization here. So I'll teach you optimization to solve the homogeneous matrix, this one. So that's the important part in chapter 4. And I also teach you what's the vector. You learn the linear algebra. You learn the vector. So what's the physical meaning of the vector? Vector 在的物理意义是什么? Because when you do the coding, programming, the input is a vector or matrix. The output is vector or matrix. The parameters is homogeneous matrix. Okay, input is a vector or matrix. Output is a vector or matrix. But all the parameters, like a deep learning, they have about like 0.1 the millions parameters all together in a homogeneous matrix. And how do you solve it? And that's called optimization here. So I teach you. And then finally, except the camera modeling, what's the application of camera model? Okay, we call motion transformation or geometric transformation. You have only two kinds of transformation. One is affine transform. So this affine transform. The other is perspective projection transform. So usually two types of transformation. 就转换式 2D to 2D, 2D to 3D, 3D to 3D, the transformation. So 2D to 2D or 3D to 3D, the transformation we apply is an affine transform. So what's affine? I will teach you. Usually rotation translation. Okay, rotation translation, that's affine. Okay. And the third one is the perspective projection. Okay. So that's for this lecture. Okay, so camera model, we have 5 chapters. So back to the chapter 2. Here. So the pinhole camera model I already teach you is this one. So this is a basic concept, a basic concept of pinhole camera model. So pinhole camera model has 3 coordinates. One we call world coordinate, 世界坐标 world. So world coordinate, it usually is an object coordinate. Like I'm an object. You find your target, that's an object. Okay. But in all the coordinate, there's only one world coordinate, only one. So suppose we have like 50 students here, but you only can choose one person, and that person is the center or her center will be world coordinate. Other objects were related to that one. Okay, so world only has one because you try to reconstruct the scene, so it's only one world coordinate. For the camera coordinate, 3D camera, you can have many cameras. So we can have many cameras here. Now all the cameras, they take a look, they look at only one world coordinate. So world only one. The camera has suppose we have 5 cameras. So I have a 5 camera coordinate. That's 3D. And each camera coordinate has one image coordinate. This one. There's 2D. So each camera has 1 2D image coordinates. So that's meaning we have 5 camera. That means we have 5 corresponding image coordinate. So let's become this coordinate. Okay. And I talked about the 3D to 3D or 2D to 2D. The relationship we call affine transform. I'll talk about later. But what's affine transform? They include rotation, include translation. That's it. 任何对等的坐标 3D 到 3D 或 2D 到 2D 就是位移跟旋转。So that's this one. It's coordinate, right? You can translate and rotation. So I only have a rotation and translation. For the rotation, usually we use the Euler angle. So what's the Euler angle is this one? So each axis has a rotation angle. So like this one, we have a omega phi and k, and we see I'm sorry. Here, okay. It's page 27. So each axis has rotation. 每个轴它都有旋转坐标嘛，旋转这3个。Here, the definition, how we call this one, we have a low rotation. Low is this one, right? And pitch is like a pitcher through the ball. So pitch is up down. Okay, so pitcher is this way. So this way. So in this case, pitch is y. Y here, y. Okay. And then yaw is this way. So you roll this one. So here xy here, xy. And z is depth. Even z axis is depth. 深度嘛 z. So z here, this is low rotation. And once if we use the right hand, so x, y, and z, or x, y down, x, y, and z. Okay, so this way. And we have one is in plane rotation, the other out of plane rotation. That's important. In plane rotation is meaning it's affine transform. Is that in plane is like the same plane. So it don't distort. It's without distortion. Okay, so in plane rotation. So that's affine. Why? It's only the rotation and translation. Okay. And out of plane rotation, is in the lecture is here in pages I think 73. Okay, this one. So closer to you become bigger. Away from you is become smaller. Okay, so I do this way. So close to you is bigger. Far away from you is smaller. So it's distorted. Or this way. Or this way. So close to you is become bigger. Far away from you becomes small. So this way. So both is distorted. So we call out of plane rotation. So there's a perspective projection transform. We have affine transform. affine 是刚性的，affine， affine 是刚性，刚性是不变形嘛，affine transform 就看到是不变形的。那 perspective projection 或 perspective transform 是投影的，那会变形，就是会有 in pinhole camera 就是有这种 scaling 的问题，是这样。那这个定义要知道。Okay, so that's the Euler angle, that's the rotation. So no matter we do like my lab, we do a robot arm, they have a rotation translation. And 有这种，比如说 they have a rotation translation。哦，你要是那个无人驾驶车，那个无人飞机啊，或是那个 vehicle 那个无人驾驶的车子，那些都有这些坐标转换啊 ，GPS 那些。好，那这上次我提完了。OK。So we start to talk about the lecture today. So one important one is that I go back to here. This page is 39. So we have world coordinate. We have a camera 3D coordinate. We have an image coordinate here. Okay. So from the 3D to 3D, so this world to camera coordinate, we have a rotation, we have translation, and rotation parameters as a rotation x, rotation y, rotation z. Because it's 3D, so each rotation has 3 components. 3 components. So total, there are 9 components here. And translation only has 3 parameters. It's tx, ty, tz. And plus meaning orthogonal. It's meaning they don't have a correlation. That's independent. That's meaning you can do translation first and rotation. Or you can do the rotation first and do the translation. So that you do a linear combination. The plus is meaning this term and the other term are separated, is separatable, or is independent. 独立的，独立就可以分开解。Okay. So this we call extrinsic parameters. And they have a 6 degree of freedom. What's degree of freedom? Degree of freedom 就自由度。Okay, so here we have Rx, Ry, Rz. So we have 3 degree of freedom for rotation. Even though they have 9 components, however, we call this only Rx, Ry, Rz. 就它虽然有9个参数，但等下定义就是每个参数每个 rotation 就 Rx。那记得 Rx usually like this one. This Rx, Ry, Rz. 但是这个是把它写成 matrix 形式啊。基本上它是3个位，这3个这个 Rx 3个未知数。3D 嘛，3个未知数，2D 就2个而已。然后 3 translation are X, Y, Z. Okay, so this is the 3D to 3D. What's the intrinsic parameters? That one is from 3D to image plane. So this is also called projection matrix. Projection. This is affine, and this is projection from between 3D and 2D. And this is people try to formulate it. 这是人家定义出来的啦，是的。那上可以解。那我待会继续讲。So in this camera pinhole model, the z-axis here we call optical axis. So the z-axis, no matter is positive or negative, here we call optical axis. And the image plane here, the optical axis will pass through one point. This point is called principal point here. Principal point. Because sometimes optical axis also called principal axis. Like a PCA, we call principal component analysis. So principal actually is called principal axis, but here we call optical axis 光轴。那这个交叉这一点就称为 principal point. Principal point is not origin point. Origin is 0, 0. That's you define. 原点是你定义的哦。So we call origin point. For example, I can define origin point is a top left corner. I can define this one. So it's up to you. Okay. But usually when we process the 2D and 3D relationship, we will translate this origin point to principal point. Oh, this is important. When you do the 3D thing, see it's the 3D coordinate 0, 0, 0 here. Camera 3D camera coordinate 0, 0, 0 is here. The origin here. But where is the 0, 0 in image plane? It depends on you. So when you read the image, right, read into the inside your buffer, your computer, usually the image, the left top, this one is a 0, 0. The screen you display, the left top corner is here, is a 0, 0. However, when you do the 3D, 2D, do the transformation, rotation, translation, this is, don't define this one to be 0, 0. For example, check. Okay. Suppose this is a plane, right? If you define this one is 0, 0, when you do the rotation, you'll do this way. That's incorrect. Because when you do the rotation, usually in the center here, and this rotation will be correct. Because you access here. Suppose you access here, right? You access 这个轴在这里. When you do a rotation, and all the coordinate will change. But if you move the center here to this center, or move this one to center, and this your rotation, suppose 30 degree, you do 30 degree, and this 30 degree. So here is 30, right? This is 30, and this is 30. So this is correct. But if you do the corner is here, you do 30 degree. Okay, and all the coordinate will be, because this is this coordinate, right? If you move it here, it's negative. Or if I do this way, this positive, I moved it here, and this negative in y direction. This positive. I say the 4 coordinates, 4个坐标嘛，你这样移就会外掉，整会外掉了。好，我先讲这个哈，所以这个小细项那个3D 到2D 坐标转换，这个平面最好是中心点是0，不然你会整个会乱掉。所以怎么做？ So usually the image you do this way. If we do the 3D, the relationship between 2D and 3D is that usually we move the origin to the principal point and do this kind of a process. After we transfer all the process, and finally when you try to display, you move back to from the principal point back to the top left corner for the display purpose. 你要在做的时候，通常是把这个坐标先移到那 principal point 的这一点，然后做完这些转换处理，2D、3D 处理完以后，当你要显示的时候，再把这个坐标转回来，不然你会错乱掉。那这是学生常会发生错误的地方，注意一下。那另外上次有提到哈 ，Last time talk about this optical axis intersect with the image plane here. This point is not the center of this image. 不会是中心，不会在中心点 ，absolutely not. Because the mechanical problems or optical problems. So even though the same brand of the camera, the image center won't be the same. 你同一个品牌说，同一个品牌的摄影机，它的影像中心点不会一致哦。那这个会造成什么状况？会造成 bias. Bias meaning when you feel this. Suppose if you this is 600 by 400, and the center with 300, 200, right? No, it's incorrect. So when you see this image center, and I do the mark, right? So suppose we have drawn to attack some target, and you see, if it's a close marker, you find the target, right? And then you use a missile and then attack the target. Sorry, it won't correct. Because what? Because the center is not the real center. So we need to do the calibrate. So what's the center? Is alpha, beta. So center is here. So we define alpha and beta U0 and V0. Sorry, this one. Let's call principal point here. So we need to calibrate for the higher precision result. If you want to have a higher precision result, you do the calibration. So next chapter, I will talk about how do you do the calibration of the intrinsic parameters. This one. 就是内部参数是只能用校正出来的，除非 if you don't care the precision too much, that's fine. 你只要不是很计较这么精准的话，那这个可以用中心点。But for the high precision calculation, this one need to do the calibration. So next chapter I'll tell you how to do the calibration for U0 and V0. Okay. So this intrinsic parameter we call intrinsic parameters is here. Actually, is here between 3D camera coordinate to 2D image coordinate. So they only have 5 parameters for intrinsic parameters. One called principal point. Okay. The other we call skew factor here. What's a skew factor? But currently the camera is good. We don't have a skew factor. Skew factor, so it's like this one. 这有点虚哦，我给你看一下，有点像这样。那它整个本来是平行，本来是那个正方形90度，它跑掉了。那现在这种比较少发生，所以 right now the skew factor can be 0. That's meaning we won't affect the result. This can be 0 right now. But 20 years ago, the camera still has a skew. Okay. And finally, the most important one is the scale factor. alpha, beta. So the most important principal components, the intrinsic parameters are alpha and beta. And this usually is a focal length. Focal length, 焦距. So the most important intrinsic parameters are the focal length, 焦距. Because focal length is, if you have longer focal length, that's meaning your zoom in is bigger. So like you take the photo, if you have a long lens, right? The focal length is longer. The far away object will be close to you. Okay, so the scaling, in reality, scaling will affect by the focal length. And how can you calculate this one? It is we call camera calibration. So camera calibration try to calibrate the 5 parameters. Okay. Now what's alpha and beta? Alpha usually is called minus is just the direction. Okay, minus is meaning the direction of a z. If you do like this way, x, y, z, that object is there. So z is that way. So all the object in the negative z direction. So in that case, will be all the component will be minus. So that's this one. If you define here, right, this one. If you define z is in that direction, so like x and y, so x, y, z that direction, so it's positive, and then this one will be positive. So the sign is only for the direction of z. And what's Ku and Kv? Ku, Kv we call aspect ratio. What's aspect ratio? It's meaning in the cell, in the sensor, the CMOS sensor, for each cell, what's the ratio between W and H? 就长宽比啊。那 usually 长宽比是 1:1， 你的 cell 的长宽比 ratio always 1:1， 1:1，那你出来会变形。So Ku, what they call Ku and Kv, the ratio we call aspect ratio. Usually this here is 1. So 1 is meaning alpha and beta equal to focal length. So alpha beta is focal length. 就你把 alpha beta 当成 focal length 这样子。So this is intrinsic parameters. So again, the camera model has if this world coordinate x, y, z capital. After rotation translation, you project to here. Sorry, not project, sorry. It's a transform to here. Will become camera coordinate. From camera coordinate, you project to 2D. So this image coordinate. And if you combine all the parameters together, you multiply together. The 3x3 matrix times 3x4 and become 3x4 is this one. So this world, and this is image. And here, this homogeneous matrix include the intrinsic parameters, extrinsic parameters. Okay, so that's what I try to tell you. So we back to here, back to page 37. So we have a world coordinate here. We have a camera 2D image coordinate here. And this is extrinsic parameters include rotation, translation, this is alpha and transform. And we have a camera intrinsic parameters here. Camera intrinsic parameters for each camera has only 1. So you only calibrate 1 time, and that's it. 每一组的相机的内部参数只有一组而已，不会改变。所以你只要 calibrate 一次，就假设说我把摄影机 before you set on somewhere, you do calibration first. After you do calibration, you know what's the intrinsic parameters for the camera, and then you can set up the camera to anywhere. You don't need to calibrate again. So the intrinsic parameters for each camera has only one. However, I said the same brand, 相同品牌 brand, but different camera, the intrinsic parameters are different. 会不一样哦，每一只摄影机它都不一样，包括 focal length 也不一样。所以他跟你讲 ，suppose you buy a camera, they call this focal length is 12 millimeter. In reality, not 12. There was some offset. 有一些误差这样子。好，那回到这边 ，So how can we solve this one? This is not homogeneous matrix because two matrices together, sorry, separate are not homogeneous. Homogeneous matrix is only one. So you time both together, become 3 by 4, like this one. So only this one called homogeneous matrix. This is not homogeneous matrix. Okay, so how can we solve this one? That's calibration. We try to solve the parameters we call calibration in camera. But if you solve all the parameters in deep learning, you just solve it. They don't have a define. You solve it using stochastic gradient descent to solve it. That's it. But in camera, we call calibration. Okay. So this format we call MX equal to B format. It's called homogeneous matrix format. Or we call AX equal to B. So what's X? X input. What's B? B is output. And you try to solve the homogeneous matrix here. After you solve the homogeneous matrix, any input X, Y, Z, you can get the output here. Even though you do the deep learning the same. Deep learning, you input image here. All the parameters are here. Your output, what's your output? Sometimes your output is labeling, like a face, you label 1. Non-face, you label 0. It's labeling. Sometimes the other, like the other image, it will be image. So up to you. So the input and this output and this parameters. So we all solve this kind of problems. Okay, so computer cannot recognize this one. No, this is a linear combination. 电脑没办法解这个。So computer only can solve is this one. Okay, so that's why the homogeneous matrices are important. So how can you do that? Suppose you have equation here, right? And how can you solve it? And then you should try to use your script, 你的那个纸去把这个弄出来。So you should transfer this one to the homogeneous matrix format. So you write a computer this one. Where the coding is this one. And call the optimization method, they will solve for you. Like you do the deep learning, you call stochastic gradient descent, and they'll solve for you. Okay, but this is not the final answer because the final solution is here. You want to solve suppose you want to solve Suppose you have a correct input data, correct output data, you can solve this one, right? So you have solved the parameters. However, your final result, you want the output here, right? You have this training, you collect all the data, and you try to train. The training is meaning you try to solve like loss function. You try to solve the parameters. So after you solve the parameters, your inference is, for example, your input here, you have parameters you want to output here. Okay, so your result is that after you get this result, no, it's not complete yet. You need to divide it by this called scaling term here. So this is your final result here. 注意一下，你的最后 output 的是这个才是你最后 output。 但是在解的时候，这个没办法解，因为这是线性的 linear combination， 这没办法解。那怎么办？所以你有收集一堆 training data 在这里，你有收集你的 labeling output data 在这里，就 output 的 labeling 在这里，根据你的 input 跟 output， 你去解这一大堆的参数，解出来了 ，training 结束了。那 training 结束，你要开始做 inference， 那 inference 就不用 loss function， 不用解了，因为你已经有参数了。那 inference 一样，你就把输入带进去，它是把结果弄出来，这就结果。而这个结果不是你最后要的结果，这个结果它事实上还要，因为这是一个 scaling term， 这是我们你原来 data 是没有这个 term， 没有这个 term， 那你把它加一个常数项，这个 term 事实上就是在分母，我们称为 scaling term 常数项，是在分母的 term， 所以最后结果是要把原来的 exponent 再除以 scaling term， 这个才是最后结果。那你deep learning可能你不用在乎，你 inference 好像没有在在乎这个嘛，就把它丢进去就出来了，因为他帮你弄好了，他帮你把这个弄好了，所以注意一下。但实际上是还要除以你的分母这个 term， 这样子。那分母这分母的 term，if the denominator，so this term is the denominator parameters， 分母的 term。If this is 0, 0, 0, 1, and that's linear. That's meaning your denominator only have a one constant here. That's meaning the linear term. If you have a x, y, z, so these three are any one are not 0, and that's meaning that's a perspective. That's meaning it's nonlinear term. So if you have a denominator term, that's meaning you are nonlinear process. Okay. So this is for the homogeneous matrix. So back to continue. So next page is so I talk about this one. But usually we solve is this one. So this is we see this one is sum square difference. If they have a divided by, so total number is data is n. So if you divide it by n, that's meaning mean square error. So if you mean square error, that's for deep learning. Deep learning use mean square error. Why? Why need to divide it by total number? Because that's batch size. Okay, but for the machine learning, because they don't have many parameters, so they put all the data. They don't need huge data. They only need some data. So they can put all the data together and solve it. That's the machine learning. Deep learning need huge data. So they cannot do that. So we need a batch size. So we divide it by several batches, several groups. And each group has different number of data. So it's up to you. So that's why deep learning need to divide it by total number of batch size. Deep learning 跟 machine learning 不一样啊 ，machine learning 就把所有 data， 因为它参数不多就丢进去就解出来。那 deep learning 因为大量资料，你要把它分成好几个 group， 那称为 batch size。batch， 那因为 batch size 是我们都不知道，是你自己决定的，所以这个参数 batch size 里面的个数，你讲 for example suppose if 1,000 images, but for machine learning you just put 1,000 inside there, they solve it, so they can use sum of square difference, this one for machine learning. But for the deep learning, because it's you use stochastic gradient descent, they need a lot of iteration. Stochastic gradient descent, you want to solve the solution, they need a lot of iteration. So that's why if you do a deep learning, you need to do the batch size. So I say, so for the 1,000 images in deep learning, suppose you divide it by 10 groups. Each group has 100 images. So here, you need to do 100 here and divided by 100. So in the deep learning, they don't use sum of square difference, they use mean of square difference 这样子。这样知道 ，deep learning 是用平均值，因为你的 batch size 是你决定的。那 deep learning、machine learning 不用，就全部丢进去就好了。所以 machine learning 用 sum of square difference 这个 ，deep learning 用 mean of square difference， 因为它要除以100，就100个 batch size 还是100张，就除以100这样子。这两个不一样在这里。好，那所以 suppose so this if this no matter is a mean or sum of square difference square 在这里嘛 square difference 是相减。那 this is a ground truth and this is the estimation result. So this is AX. So this estimation result equal to the AX or MX, so equal to homogeneous matrix here. And that's called loss function. This is called loss function. Okay, so here I zoom in. I would like to use this figure to explain. So we have a world here, world coordinate here. We only have an image. So how can we find the parameters here, between here? What I try to say here is that you have only camera. You take a photo. You take an image. So this, you know, you see the image here. But how can you try to find the relationship between 3D and 2D? That's why we want to do I want to introduce what's the camera model. How can we do the calibration? 就在我们实际世界上，你有看到影像而已啊，可你怎么把这 3D 恢复回来 ？And we back to here. In page 5 here. I say, in the world, here is a scene, 3D scene here. We have a camera, it's 2D. But for the computer vision, we try to reconstruct from the 2D image to the 3D model, 3D object. And after you have 3D object, you can put into the AR, VR for the graphics people, or AI is computer vision people to do the process here. Okay, so right now I try to say that what you can get is an image here. Okay. So back to so in reality we can see it here. We only know this one. So what's the relationship between both 3D and 2D is that in 3D you have a rotation translation. You need to transfer to 3D camera coordinate. And then based on here, you need to find the intrinsic parameters in order to project to 2D, this one, image. But this one is undistorted. In reality, in the theory, this undistorted. 这里没有变形。什么叫变形？ This one. So this, what I say is this one. You take a 3D, right? And you project to the 2D, should be this one. However, the image we take is this one. They have a distortion here. The straight line become a curve. Why it happened? Because the lens will cause the image distorted. So this is what you see. So this image, this one, is this one. Sorry, this is distorted and this is undistorted. So this one corresponding to is this result. This is what you see, and this is undistorted. But you cannot see this one. Okay. So that one is this one. And we see, what we can see here, because they have a dense distortion here. So camera calibration, you try to solve, give you 5 parameters here, 5 parameters here, and you do calibrate this one. So after you find the distortion parameters, after you find this one, we can reconstruct from 2D to 3D. So that's this one. So we put this 3x4 eccentric parameters and combine with the intrinsic parameters, combine both, become this one. But this one also include distortion. But don't worry about that. We will talk about that one in next week. In the chapter 3, talk about this one. Okay. 所以这个我只要帮你弄出来说，你目前看到是这里而已，你看不到这个，这是校正出来的，这样子。那你又问我说，老师，那万一假设摄影机上面，你又没办法校正，怎么办？If your camera is up to already there, you take the photo. How can you reconstruct that one? So if you want to do the precisely reconstruction, you need to find the distortion and calibration. The distortion parameters, the intrinsic, both are the important one. 这两个最重要。你要做很精密的重建，就需要去做 calibration. But however, if you don't want to have a very precisely reconstruction result, you don't need to calibrate this one. You only need to calibrate this one. You don't only need to solve this one. 就是你不要做那么精密的话，因为从这里到这里总共就12个参数，你就是解这个就好了。解这个，那这个就是这个啊，就这个。我再讲一遍，假设你要做很精密的重建，很准的重建，你就要解这个，解那个这内部参数要把它解出来。假设你不知道这个怎么办？还是可以做，就是为什么那么多 paper 在做这个啊？从摄影机做很多 3D 重建就在这里，你还是可以做。那就是解这个，就把这12个参数解出来。好，那这里最重要的，所以大部分世界上没那么美好啊，摄影机都在那边，人家拍的照片，你不知道摄影机怎样，对不对？那你有影像，你怎么解这个？那是有很多 paper 在做这件事情。那 how can you solve this one? Think about that one. There are 12 unknown parameters. So how many equations we want to have in 3D? We need to have a 4 corresponding point in order to solve this one. See, I just write this one this morning. We have 11 or 12 unknown parameters of perspective projection matrix. This perspective projection matrix. So how many corresponding points in order to solve this one? At least 4 points. 要至少4个点。所以意思是什么？意思是说，在空间中只要一个平面，平面就有4个点，你就可以把这个解出来。越多点越好，越多点越好，因为你要解联立方程式嘛，所以至少4点嘛。因为你要解这个，至少4个点啊，至少4个点，那越多点越好，这样子。所以你要在地上，只要地上可以发现4个点，你就可以把很多3D 的东西重建起来。那这就是 AR。你怎么做 AR？ how can you do the AR? So when you use your cell phone and you want to do the AR, 你现在玩那个很多 AR 的 APP， 他有没有跟你讲，它地上要有一个平面在地上，因为它要去自动找那4个点。所以 when you do the AR， 我们会做 AR， 你要做 AR 最重要是什么？要地。记得你做 game 嘛？什么 AR 的 most important one, you need a plane because the plane is the basic, so any object can stand on the plane. If you don't have a plane, your object will pass through the plane， 就怪怪的。所以你要一个面。所以 when you do the APP of AR, they will define the plane is the desk or the ground。你要跟他讲，自己玩 AR 就知道了。一定会有这个，那就是讲，我就讲这个，因为他要解这个，他把这个解出来。好，那所以我们至少要4个点，那就可以解这个。那问题又来了，那你这个解出来以后，那这 S 怎么办？这有3个呢，你不是坐标只有，老师你音像只有 XY 啊，你没有 S 啊，那还是解不出来啊，那怎么办？那只好把 S 当1。所以 what's the factor of S? S is the focal length. S is the focal length. 你如果把那个，我是把这个解开了，你这解开，你发现 S 跟 F 有关。S 是 scaling turn，scaling turn。那所以这个 S 这个 turn 就 scaling 就 focal length。So if you can get the focal length, you just put here, you got the 3D. If you don't have focal length here, you don't have focal length here. 但自己注意一下，那个这里的单位要注意哦。The unit should be careful. The unit is a pixel, or the unit is a millimeter or centimeter. Should be careful. When you do the camera calibration, the result is a pixel. The unit is a pixel. This is a pixel. However, in reality, it's a centimeter or millimeter or meter. So you need to transfer. 那我上次我刚才跟你提过那个 How can you calculate this one? You should based on this one. 你要去查这个。你要看到摄影机的规格，去查这个。这个就是在跟你讲一个 pixel 等于几个 millimeter 嘛。你要查这个 ，you can find from this sheet in the internet. So both pages are the relationship between pixel and the millimeter. And back to here. So S is the focal length. So first, you can do the calibration, or because if you don't want to have precisely, you can just find the sheet of the lens， 你就把那个 lens 的那个找一下个 lens 是哪一个几 millimeter 的东西，就把这 focal length 把它写进来就好了。那最后 suppose you know nothing about this one, you can put 1. Just put 1 to here， 就把它当成一个单位。那什么叫1？就 focal length 等于1。那1的话，你会发现做出来物体会变小小的，但是它比例是对的，它 XY 比例是对的。那到时候你再把它放回去，懂吗？你这个如果假设是1的话，你就解出来了。那解出来的时候，你的物体看起来因为 3D 啦，看起来小小的，那我再把它放大1倍变2，就变大，因为它相对应放大嘛。放大10倍就变成更大这样子。所以很多软体，有没有那个什么 Mesh Lab， 很多软体你在玩很多 scaling 软体，它就那实际上是叫做什么？以前叫什么什么 Graphics， 就是一个软体，让你忘记了，它就可以放大放小这样子。所以很多软体就是让你 scaling turn 就让你放大放小，就调这个，这样就解出来了。课本不会跟你讲这个，课本只给你数学式子。好，还是休息一下比较好。所以 take 10 minutes break，大概是18分左右，我们休息一下。签这个。